In 1977, humanity embarked on one of its most ambitious endeavors, launching 2 spacecraft carrying golden records containing the essence of our world. These remarkable time capsules aboard Voyager 1 and Voyager 2 carry the sounds that define our existence: the intimate whisper of a mother's kiss, the pure innocence of a baby's first cry, and the rich tapestry of human language expressed through greetings in 55 different tongues. Today, these cosmic messengers continue their eternal journey, having crossed the threshold of our solar system into the infinite expanse of interstellar space, serving as ambassadors of Earth to any civilizations they might encounter in the distant future. Yet this extraordinary achievement represents just one fascinating chapter in NASA's remarkable saga of space exploration. Since its inception, NASA has continuously pushed the boundaries of human achievement, from the historic moment when Neil Armstrong left humanity's first footprints on the lunar surface to the present day, where sophisticated robots traverse the rusty terrain of Mars, sending back invaluable data about our neighboring planet. These missions have fundamentally transformed our understanding of what humans can accomplish when driven by curiosity, determination, and innovative spirit. As we delve into this cosmic journey together, we'll explore 3 pivotal aspects of space exploration that have shaped our understanding of the universe. First, we'll revisit the intense space race that culminated in the Apollo program, a testament to human perseverance and ingenuity that turned the dream of walking on the moon into reality. Then, we'll follow the extraordinary voyage of the Voyager missions, which gave us unprecedented views of our solar system's outer planets and continue to send data from the frontier of human exploration. Finally, we'll examine how these historic achievements have influenced modern space exploration, inspiring new generations of missions and technological innovations. This journey through space and time showcases humanity's endless quest for knowledge and understanding of our cosmic neighborhood. Whether you're a long-time space enthusiast or just beginning to explore the wonders of space exploration, these stories of human achievement, scientific discovery, and technological innovation will captivate your imagination and demonstrate the remarkable progress we've made in our journey to the stars. If you're ready to embark on this fascinating exploration of humanity's greatest space adventures, join our community of space explorers as we uncover the mysteries of the cosmos together. The Apollo program stands as humanity's greatest achievement in space exploration, marking a pivotal moment in human history. It all began on May 25, 1961, when President John F. Kennedy made his bold declaration before Congress that the United States would land humans on the moon and return them safely to Earth before the decade's end. This audacious goal came during the height of the Cold War, transforming the space race into a symbol of technological and ideological supremacy. The path to the moon was not without its tragic setbacks. On January 27, 1967, during a routine test, fire erupted in the Apollo 1 command module, claiming the lives of astronauts Gus Grissom, Ed White, and Roger Chaffee. This devastating loss led to a complete overhaul of NASA's safety protocols, resulting in crucial modifications to the spacecraft design, including a new quick-release hatch and the replacement of flammable materials with fire-resistant alternatives. Behind the scenes, thousands of dedicated individuals worked tirelessly to make the moon landing possible. Hidden figures like Katherine Johnson, whose mathematical calculations were crucial for orbital mechanics, and Margaret Hamilton, who led the team developing the Apollo guidance computer software, played indispensable roles. The seamstresses who hand-stitched the spacesuits, the engineers who designed the Saturn V rocket, and countless others contributed their expertise to this monumental endeavor. Apollo 11's journey to the moon captivated the world in July 1969. As Neil Armstrong and Buzz Aldrin descended toward the lunar surface in the Eagle lunar module, Multiple alarms blared in the cockpit, warning of computer overload. With remarkable composure, they continued their descent, manually navigating past a boulder field to find a safe landing spot. With only 30 seconds of fuel remaining, Armstrong radioed the historic words, "Houston, Tranquility Base here. The Eagle has landed." Hours later, as Armstrong stepped onto the lunar surface, he delivered the immortal phrase, "That's one small step for man, one giant leap for mankind." Did he? Though he had planned these words carefully, the moment's magnitude led to a small but significant omission of the article "a" before man, slightly altering the statement's meaning. Nevertheless, these words became eternally etched in human history. The success of Apollo 11 was just the beginning. The program continued with several remarkable missions, including Apollo 13, which demonstrated NASA's incredible problem-solving capabilities when an oxygen tank explosion threatened the crew's lives. The ingenuity of both the astronauts and mission control transformed a potential disaster into what Flight Director Gene Kranz later called a successful failure. The Apollo missions yielded unprecedented scientific discoveries. The 842 pounds of lunar rocks and soil samples returned to Earth revealed the Moon's volcanic past and helped scientists understand the solar system's early history. These samples continue to provide new insights even today, as advancing technology allows for more sophisticated analysis. The Apollo program's technological legacy extends far beyond space exploration. Innovations developed for the Moon missions led to numerous everyday technologies we now take for granted. These include memory foam, cordless tools, scratch-resistant lenses, and significant improvements in computer technology. The miniaturization of computers required for the Apollo guidance computer helped pave the way for personal computers and modern smartphones. Perhaps most importantly, the Apollo program demonstrated humanity's ability to achieve seemingly impossible goals through dedication, innovation, and collaboration. It showed us our planet from a new perspective, a beautiful blue marble floating in the vastness of space, and fundamentally changed our understanding of our place in the universe. This perspective continues to influence how we approach challenges on Earth, from environmental conservation to technological innovation, reminding us that with sufficient determination and resources, we can overcome even the most daunting obstacles. The Voyager missions represent one of humanity's most ambitious and far-reaching space exploration endeavors, made possible by a rare cosmic alignment that occurs only once every 176 years. In the late 1970s, Jupiter, Saturn, Uranus, and Neptune aligned in a way that allowed a spacecraft to use gravitational assists from each planet, creating a slingshot effect to visit all 4 outer planets in a single journey. This celestial choreography, dubbed the Grand Tour, presented an opportunity NASA couldn't ignore. The engineering challenges faced by the Voyager team were unprecedented. They had to design spacecraft capable of operating for decades in the harsh environment of space, far beyond the protective bubble of Earth's magnetic field. Each Voyager spacecraft was equipped with 3 redundant computers, multiple backup systems, and radioisotope thermoelectric generators powered by plutonium-238, chosen because solar panels would be ineffective in the dim outer solar system. The engineers had to anticipate potential failures and build in safeguards that would allow the spacecraft to diagnose and often repair themselves, as no human could ever reach them for maintenance. Perhaps the most poetic element of the Voyager missions is the Golden Record, a 12-inch gold-plated copper disc carrying the sounds and images of Earth. This time capsule, curated by a team led by Carl Sagan, contains 115 images, natural sounds like waves and wind, musical selections from different cultures and eras, and greetings in 55 ancient and modern languages. The record's cover includes symbolic instructions for its playback and a map showing Earth's location relative to nearby pulsars. It represents humanity's message to the cosmos, our attempt to share our story with any distant civilization that might one day find it. The Voyager missions have had an immeasurable impact on our understanding of the solar system and our place within it. They revealed Jupiter's Great Red Spot in unprecedented detail, discovered active volcanoes on Io, showed us Saturn's rings in their full complexity, and gave us our first close-up views of Uranus and Neptune. Both spacecraft are now in interstellar space, making them the most distant human-made objects ever, still sending data back to Earth across billions of miles. The engineering solutions developed for Voyager influenced countless subsequent space missions. The spacecraft's ability to autonomously handle problems became the foundation for modern spacecraft artificial intelligence. Their communication systems, capable of transmitting data across vast distances with minimal power, revolutionized deep space communication techniques. To put these historic missions in perspective, consider these remarkable statistics. Each Voyager has journeyed over 14 billion miles from Earth. Mission duration, over 45 years and still operating. Data transmitted, over 7 trillion bits of scientific data. Power output, initially 470 watts, now reduced to approximately 270 watts. Communication time. Radio signals now take over 21 hours to reach Earth. Speed, approximately 38,000 miles per hour relative to the Sun. When considering the impact of various NASA missions on humanity, the Voyager program stands alongside Apollo as one of the most influential. While Apollo showed us our own world from the moon and inspired a generation to dream big, Voyager revealed the true vastness and diversity of our solar system. It demonstrated that worlds beyond Earth could be as varied and dynamic as our own planet, fundamentally changing our perspective of the cosmos. Looking to the future, the lessons learned from Voyager continue to influence mission design. Modern proposals for interstellar probes build upon Voyager's successes while incorporating new technologies. Potential destinations for future missions include detailed exploration of ice giants like Uranus and Neptune, which Voyager only briefly visited, or focused studies of intriguing moons like Europa and Enceladus, where subsurface oceans might harbor life. The Voyager missions remind us that space exploration is not just about scientific discovery. It's about pushing the boundaries of human achievement and carrying our presence ever further into the cosmos. As both spacecraft continue their journey into interstellar space, they carry with them humanity's hope of reaching out to the stars and our enduring message to any civilizations that might one day find these remarkable emissaries from Earth. One of the most startling discoveries in the history of space exploration came when Voyager 1 revealed that Jupiter's moon Io was not the dead, cratered world scientists expected, but rather the most volcanically active body in our solar system. On March 8, 1979, navigation engineer Linda Morabito spotted what appeared to be an umbrella-shaped plume extending about 60 miles above Io's surface. This observation marked the first time humans had witnessed volcanic activity beyond Earth. Io's surface is dotted with hundreds of volcanoes, continuously erupting sulfur compounds and silicate rock, completely resurfacing the moon every few years. These volcanic processes are driven by the intense gravitational forces exerted by Jupiter and its other large moons, which squeeze and stretch Io like a rubber ball, generating tremendous internal heat. Saturn's ring system, though visible from Earth through even modest telescopes, revealed its true complexity under Voyager's careful scrutiny. What appeared as simple concentric circles transformed into an intricate cosmic dance of countless particles ranging from microscopic dust to house-sized boulders. The Voyager missions discovered that these rings contain strange features like spinning spokes, twisted kinked ribbons, and mysterious braided patterns. The spacecraft revealed the presence of shepherd moons, small satellites whose gravitational influence helps maintain the ring structure. Perhaps most surprisingly, they found that the rings are incredibly thin, in most places no thicker than the height of a house, yet span more than 175,000 miles in diameter. This discovery revolutionized our understanding of planetary ring formation and dynamics, leading to new theories about the early solar system. Perhaps the most philosophically significant image ever captured in space exploration came on February 14, 1990, when Voyager 1, at Carl Sagan's suggestion, turned its cameras back toward Earth from a distance of about 3.7 billion miles. In this famous pale blue dot photograph, our entire planet appears as nothing more than a tiny speck of light, smaller than a single pixel, suspended in a vast cosmic void. As Sagan eloquently described it, "Look again at that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives." The photograph's profound impact stems not from what it shows, but from what it implies. Every human conflict, every empire, every achievement and tragedy in our history occurred on that barely visible point of light. The image became a powerful symbol of Earth's fragility and isolation in space, helping catalyze environmental awareness and offering a unique perspective on human conflicts. It demonstrates, more effectively than any written argument, the arbitrary nature of human-drawn boundaries and the ultimate unity of our species on our small, shared world. The timing of this photograph was particularly poignant, as it marked one of Voyager 1's final acts of imaging before its cameras were permanently shut down to conserve power. The spacecraft had completed its primary mission, having studied the giant planets and their moons in unprecedented detail, and was heading toward interstellar space. This final look back at Earth served as both a technical triumph and a philosophical capstone to humanity's first detailed survey of the outer solar system. These three discoveries, Io's volcanism, Saturn's complex rings, and the pale blue dot, represent different facets of the Voyager mission's impact on human knowledge and perspective. The volcanic activity on Io showed us that our solar system is more dynamic and active than we had imagined. Saturn's rings revealed the intricate interplay of gravity and matter in space, demonstrating nature's ability to create stunning complexity from simple physical laws. And the pale blue dot provided a humbling reminder of our place in the cosmos, becoming an iconic image that continues to influence how we think about our planet and our species' role in the universe. Together, these discoveries transformed our understanding of the solar system from a collection of distant points of light into a rich tapestry of worlds, each with its own character and mysteries. They demonstrated that even in an age of space exploration, our solar system could still surprise us, and that every new discovery leads to deeper questions about our cosmic neighborhood and our place within it. The Voyager missions, launched in 1977, continue to make history as humanity's most distant emissaries. As of 2024, both Voyager 1 and Voyager 2 are still operational, though in a reduced capacity, as they venture through interstellar space. Voyager 1, currently over 15 billion miles from Earth, became the first human-made object to enter interstellar space in 2012, while Voyager 2 followed suit in 2018, now traveling more than 12 billion miles from home. Maintaining communication with these distant travelers is an extraordinary feat of engineering and determination. The spacecraft communicate using their aging but still functional radio transmitters, which operate on just 23 watts of power, about the same as a refrigerator light bulb. The signals, traveling at the speed of light, now take over 21 hours to reach Voyager 1 and about 18 hours to reach Voyager 2. These incredibly faint signals, by the time they reach Earth, are billions of times weaker than the power of a watch battery. To capture these whispers from the edge of our solar system, NASA relies on the Deep Space Network, a collection of massive radio antennas positioned around the globe in California, Spain, and Australia. These 70-meter dishes are among the largest and most sensitive telecommunication systems in the world. The strategic positioning of these facilities ensures that at least one antenna can always maintain contact with the spacecraft as Earth rotates. The Voyager's longevity is a testament to brilliant engineering and careful power management. Each spacecraft is powered by radioisotope thermoelectric generators, which convert heat from the natural decay of plutonium into electricity. While these power sources are incredibly reliable, they inevitably decay over time, producing about 40% less power than at launch. NASA engineers have had to make difficult decisions about which instruments to keep operating and which to shut down to conserve power. As of 2024, both spacecraft still operate several key instruments, including their magnetometers, which measure magnetic fields, and their cosmic ray subsystems, which detect high-energy particles. These instruments are providing unprecedented data about the boundary between our solar system's influence and true interstellar space, a region never before explored by human-made objects. The spacecraft are currently traveling through the interstellar medium, the space between stars that contains various types of matter, including gas, dust, and cosmic rays. This region is fundamentally different from the solar system's environment, and the Voyagers are our only direct source of information about its characteristics. They've revealed that this space is not empty, but filled with magnetic fields and particles that tell us about the history and evolution of our galactic neighborhood. One of the most remarkable aspects of the Voyager's current mission is their role in defining the shape and extent of our solar system's boundary, called the heliopause. This is where the solar wind's influence ends, and true interstellar space begins. The crossing of this boundary by both spacecraft has provided invaluable data about the interface between our solar system and the rest of the galaxy. Looking ahead, the Voyagers will continue operating until approximately 2025-2030, when their power levels will become too low to operate any instruments. Even after they fall silent, they will continue their journey through space. Voyager 1 is heading toward the constellation Ophiuchus, while Voyager 2 is traveling towards Sagittarius. In about 40,000 years, Voyager 1 will pass within 1.6 light-years of the star AC +9 388, while Voyager 2 will pass within 1.7 light-years of the star Ross 248. The Voyagers carry a message for any distant civilizations that might find them: the Golden Records, which contains sounds and images representing Earth's diversity of life and culture. These records, protected by aluminum cases, are expected to remain intact for hundreds of millions of years, serving as time capsules of human civilization long after the spacecraft themselves have ceased functioning. The ongoing success of the Voyager missions represents one of humanity's greatest technological achievements. These spacecraft have not only revolutionized our understanding of the solar system, but continue to push the boundaries of human exploration, sending back data from regions of space never before visited by human-made objects. Their journey reminds us that even as we explore Mars and plan returns to the Moon, humanity's reach extends far beyond, to the very edge of known space and beyond. The legacy of NASA's historic missions continues to shape modern space exploration in profound and far-reaching ways. The Apollo program's influence can be seen clearly in the design and operation of Mars rovers, from Sojourner to Perseverance. The challenge of operating vehicles on another world's surface, first faced by Apollo engineers, provided crucial lessons in autonomous operation, dust mitigation, and robust wheel design. The Apollo lunar roving vehicle's innovative mesh wheels, designed to handle lunar dust and rough terrain, directly influenced the specialized wheel designs used on Mars rovers today. The Voyager missions revolutionized our approach to long-duration spaceflight and influenced subsequent missions like New Horizons, which completed humanity's first visit to Pluto in 2015. Voyager's reliable computer systems, capable of operating for decades with minimal intervention, became the model for modern spacecraft autonomy. The technique of using planetary gravity assists, perfected during the Voyager missions, is now a standard tool in deep space mission planning, enabling spacecraft to reach distant targets with minimal fuel consumption. The James Webb Space Telescope represents perhaps the most sophisticated application of lessons learned from previous missions. Its sunshield deployment mechanism incorporated redundancy principles first developed during Apollo, while its communications systems built upon Voyager's deep space communications achievements. The telescope's ability to operate in the extreme environment of space at temperatures near absolute zero was made possible by thermal management techniques refined through decades of spacecraft design experience. Looking to the future, NASA's Artemis program aims to return humans to the Moon by the mid-2020s, building upon Apollo's foundation while incorporating modern technology and new objectives. Unlike Apollo, Artemis is designed as a sustainable program, establishing permanent lunar infrastructure, including the Gateway space station and surface habitats. The program will serve as a proving ground for technologies needed for future Mars missions and deep space exploration. The success of the Voyager missions has inspired numerous concepts for dedicated interstellar probes. Projects like Breakthrough Starshot propose using lightweight spacecraft accelerated by powerful lasers to reach nearby stars within a human lifetime. More conventional proposals, such as the interstellar probe concept, aim to travel faster and farther than Voyager, carrying modern instruments to explore the boundary between our solar system and interstellar space. The search for life beyond Earth has become increasingly sophisticated, influenced by both Apollo's geological investigations and Voyager's planetary discoveries. Modern missions focus on potentially habitable environments, like Mars's ancient riverbeds, Europa's subsurface ocean, and Enceladus's water vapor plumes. The Mars Sample Return mission, planned for the late 2020s, will apply Apollo-era sample return techniques to bring Martian materials to Earth for detailed analysis. These future missions are incorporating unprecedented levels of autonomy and artificial intelligence, building upon decades of experience in robotic exploration. New propulsion technologies, including solar electric and nuclear thermal propulsion, are being developed to enable faster travel throughout the solar system. Advanced materials and manufacturing techniques, many derived from solutions to problems encountered during Apollo and Voyager, are making spacecraft lighter, more durable, and more capable. Communication technologies have evolved dramatically since the early missions, but still rely on fundamental techniques pioneered by Apollo and Voyager. The Deep Space Network continues to expand its capabilities, preparing for a future with multiple simultaneous missions operating throughout the solar system and beyond. Optical communication systems, which use lasers instead of radio waves, promise to dramatically increase data transmission rates from deep space missions. Perhaps most significantly, these historic missions demonstrated the importance of international cooperation in space exploration. Modern programs increasingly involve collaboration between multiple space agencies, private companies, and research institutions worldwide. The International Space Station has shown how space exploration can bridge political divides, while commercial space companies are bringing new approaches and capabilities to the field. The legacy of NASA's historic missions extends beyond technical achievements to inspire new generations of scientists, engineers, and explorers. Educational programs worldwide use these missions to teach principles of science, technology, engineering, and mathematics. The stunning images and discoveries from these missions continue to capture public imagination and support for space exploration. As we look to the future, the principles established by Apollo and Voyager, meticulous planning, redundant systems, innovative problem-solving, and bold ambition, remain central to space exploration. Whether returning to the moon, searching for life on Mars, or reaching toward the stars, modern missions build upon this foundation while pushing the boundaries of human knowledge and capability ever further into the cosmos. As we reflect on NASA's historic missions, from Apollo's triumphant moon landings to Voyager's ongoing interstellar journey, we witness a remarkable testament to human achievement that transcends mere scientific advancement. These missions embody the essence of human spirit, our innate desire to explore, to understand, and to push beyond known boundaries. The Apollo program demonstrated that with unwavering dedication and collective effort, humanity could achieve what once seemed impossible. Those first footsteps on lunar soil represented not just an American achievement, but a milestone for all of humanity. The images of Earth rising over the lunar horizon forever changed our perspective of our place in the cosmos, uniting us in the recognition of our shared home's beauty and fragility. Meanwhile, the Voyager missions continue their extraordinary journey through interstellar space, carrying humanity's message to the stars. These remarkable spacecraft have redefined our understanding of the solar system and beyond, revealing worlds of unexpected complexity and beauty. From the volcanic fury of Io to the ethereal rings of Saturn, each discovery has opened new chapters in our understanding of the cosmos. These achievements have inspired generations of scientists, engineers, and dreamers. The technological innovations developed for these missions have transformed our daily lives, from the computers we use to the materials that make our lives safer and more comfortable. But perhaps more importantly, they have shown us that the boundaries of possibility are often simply the boundaries of our imagination. Looking to the future, we stand on the cusp of new adventures. Plans to return to the moon through the Artemis program, establish permanent lunar bases, and eventually journey to Mars represent the next chapter in our cosmic story. Private space companies are revolutionizing access to space, while new telescopes peer ever deeper into the universe's mysteries. The search for life beyond Earth continues with increasingly sophisticated tools and methods, driven by the same curiosity that propelled the Apollo astronauts skyward. The legacy of these historic missions extends far beyond their scientific contributions. They remind us that when humanity unites behind a common goal, we can accomplish the extraordinary. They teach us that setbacks and challenges, while inevitable, need not define our limits. Most importantly, they show us that every impossible achievement simply opens the door to new possibilities, new questions, and new dreams to pursue. As we face the challenges of our time, from climate change to advancing space exploration, the spirit of innovation, collaboration, and determination that defined these missions lights the way forward. The next generation of explorers stands ready to write new chapters in humanity's greatest adventure, armed with technologies their predecessors could only dream of and inspired by the achievements of those who came before. Each mission, each discovery, each step into the unknown has brought us closer to understanding our place in the vast cosmic ocean. Yet perhaps the greatest lesson from these endeavors is that our journey is far from over. As we look to the stars, we carry forward the same curiosity, courage, and commitment that launched humanity's first steps into space. The question isn't whether we'll achieve new impossible dreams, but rather which impossible dreams we'll achieve next. The future beckons with countless possibilities, permanent settlements on other worlds, discoveries of life beyond Earth, journeys to distant stars. These dreams may seem as impossible today as walking on the moon once did, but history has shown us that impossible is just a temporary state of mind. As we continue to explore, to innovate, and to push the boundaries of what's possible, we honor the legacy of these historic missions while writing new chapters in humanity's greatest adventure. The story of space exploration is the story of humanity at its best, curious, collaborative, and courageous. It's a story that continues to unfold, inviting each new generation to contribute its own chapters to this ongoing saga of discovery and achievement. As we stand at the threshold of a new era in space exploration, we carry forward the dreams, determination, and daring that transformed impossible visions into reality, ready to tackle whatever challenges await us among the stars. Join our community at Exploring the Universe as we continue to uncover the mysteries of space. Don't forget to hit subscribe and ring that notification bell to stay updated on our upcoming episodes about space exploration.